Hi students, in this class we see about properties of Z transform, and the first property is linearity. So this is an important property. What it says that is the Z transform of weighted sum of the signals, the Z transform of the weighted sum of the signals equal to weighted sum of individual Z transform. Individual Z transform, right? So let us see how can we write this in mathematical format, right? So Z transform, if mathematically, if Z transform of x1 of n is equal to x1 of z, and Z transform of x2 of n is equal to x2 of z, right? Then Z transform of ax1 plus bx2n is equal to ax1z plus bx2z. You see, the Z transform of weighted sum of the signal. You see, x1 and x2 are signal. Weighted sum means these signals are weighted by the weighting factor a and b. So the Z transform of weighted sum of signals is equal to weighted weight a and b are weight sum of individual Z transform. You see, this signal has two signal x1 and x1 of n and x2 of n. So the Z transform of weighted sum of signal is equal to weighted sum. You see, weight the sum of individual Z transform. This is what linearity property. Fine. Okay, let us see how can we prove it. So what is the thing we have to find? The transform of ax1 proof. I have to prove that this will give this one. ax1n plus bx2n is equal to, what do you think? The formula is n goes to minus infinity plus infinity. X of n, instead of x of n, we have ax1 of n plus bx2 of n z power minus n. Right? Take two sums separately. N goes to minus infinity plus infinity. Ax1 of n z power minus n plus n goes to minus infinity plus infinity. Bx2 of n z power minus n. A is constant outside. Take outside. N goes to minus infinity plus infinity. X1 of n z power minus n is x1 of z. Similarly, take B outside. Then sum of n goes to minus infinity plus infinity. X2 of n z power minus n is x2 of n z. So now it is proved. Clear? This is what I have to prove. I got it. So hence proved. Fine. Okay. And the second property is time reversal. Time reversal property. Time reversal. What this property states, if Z transform of x of n is equal to x of z, then Z transform of x of minus n is equal to x of z inverse. That is equal to x of 1 by z. What it's telling? Time reversal. You see, if x of n, the sequence is x of n as Z transform x of z, then time reverse. You see, x of minus n is time reversal version of x of n. So Z transform of time reverse signal is equal to x of z inverse. That means you replace z by z inverse or 1 by z. Right? Okay. Let us prove it. Proof. What I have to find? I have to find Z transform of n goes to minus infinity plus infinity x of minus n. X of minus n, z power minus n. So what I am going to do, let me substitute n minus n, right? because I have Z transform equation for plus n only. So let me substitute minus n is equal to m. So what will happen if n is minus n is equal to m? Wherever I find minus n, I have to replace with m. Okay, and you see n goes to minus infinity to plus infinity. If n is equal to minus infinity, what will happen? This implies m becomes plus infinity. If n is equal to plus infinity, m becomes minus infinity. Okay, I made everything in terms of m. So n is equal to minus infinity to plus infinity means m varies from plus infinity to minus infinity. So sum of 1 plus 2 plus 3 is equal to 2 plus 1 plus 3 plus 2 plus 1. Both are same only. So when n varies from minus infinity to plus infinity, m varies from plus infinity to minus infinity. That is equal to minus infinity to plus infinity. Yes or no? Because 1 plus 2 plus 3 is equal to 3 plus 2 plus 1. So both are same only. So instead of writing like that, I write it like this because it will match with the general format. I have to replace minus n with the m. So x of m, z power m. Clear enough? Okay, then what I do? I change it. Summation m goes to minus infinity plus infinity. X of m, z power minus 1. Sorry, minus m. Minus 1 minus m. So you see it is equivalent to, right? What is the transform of x of n? The transform of x of n is summation n goes to minus infinity to plus infinity x of n z power minus n, right? So you see if z transform of that is equal to x of z, right? Here you see z power minus n is nothing but z of minus n. So here if it is z, it is x of z. Here everything in terms of m or n, but that's a variable. So if it is z, here x of z. Here we don't have z, here we have z inverse. So it must be equal to x of z inverse. Clear or not? So that's the thing. So you see, compare these two equations, compare this equation 1, equation 2. In equation 2, you see for the z transform of x of n, I write as x of z, that is equal to this one. So for x of z, here you have z, so x of z. Here we have z power minus 1, so we will get z x of z power minus 1. Fine. So when you have a time reversal signal, z transform is replaced by z inverse. Right. So now it is proved. Hence proved. So this is equal to z transform of x of minus n. Clear or not? So x inverse. I hope you understand both the properties clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.